Okay, so for the next part of your kinematics itself, we'll be actually be learning about your different types of graphs itself and how to interpret them. So first thing, whenever you have a graph, the first thing you want to do is actually check your axis. What kind of graph is this? Is this a displacement time graph? Or is it a distance time graph? Okay, basically the two graphs are very, very similar itself. And do take note that distance will never have a negative distance because it's a scalar quantity, and your displacement will have a negative displacement. Okay, so do take note, this is in the format of a y against x graph. So y is your vertical and x is your horizontal. Okay, so for those who don't understand what is a displacement time graph, it means that displacement is your y-axis and your time will be in your horizontal axis. Okay, so number two itself, you want to check your units. Are they all in SI units? Do I need to do any conversion for them? Okay, third, and is the one that is a little bit more special, is actually what is your gradient. So gradient is actually y2 minus y1 over x2 minus x1, right? So in this case, this is your displacement. Now for displacement, right, we actually use s. So s is actually not your speed, s is actually your displacement, and then d is for your distance. Okay, so yes, you can use d itself if you feel like it's more uncomfortable for you to use s. But basically, once you go up to higher levels, basically you will see that it represents displacement a lot more. Okay, so in this case, let's use s. We just clean this up. So it's actually s2 minus s1 over t2 minus t1. So you actually notice this is your change in displacement over your time taken. So if you think about it, displacement over time, this will actually give us velocity. Okay, so for most of you who are still new to this chapter itself, velocity is your rate of change of displacement. So it's the change of displacement per unit time, which is what you see over here. Okay, so that is gradient is your velocity. Yes. Okay, so your gradient is the slope of your line itself. Okay, so whenever we want to describe a graph, any graphs, we always make use of your gradient itself. All right. So because I have a horizontal line, your gradient will be zero. Because if you think about it, if your displacement is 80 meters per second, 80 meters throughout these 16 seconds, basically what it means is this person did not move for 16 seconds. So because he didn't move, there is no velocity, there is no speed. So what it means is he didn't move. He is stationary. The object will be stationary. Okay? So do take note, your displacement don't always have to be zero if you are not moving. You can be at a certain distance from your starting point. All right? Next, which is the one that you'll see very, very often, this is a diagonal straight line. So you actually have moving with constant velocity. This is a diagonal. Okay? And if you notice, this is a positive upward sloping. Okay, so this is upwards sloping. What this means is that this is a positive gradient. Okay, so because you have a positive gradient itself, this means that your velocity will be a positive value. Okay, so now to the more upper side stuff is that you will see a curve. So what do you mean by a curve? So curves, as you can see on top and below, there are two different types. So first thing, before we do anything, both of these are both upward sloping. Okay, so basically both of them are still positive velocity. Okay, this is also positive velocity. What does that mean? You are moving forward. All right. Now, on the other hand, let's take a look at your slope. You can see that your slope is actually getting steeper and steeper, steeper and steeper, 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 right? So for this one, when you have a steeper, it means I have increasing gradient. So if I'm increasing gradient itself, let me keep my ruler. Basically, what does that mean? I have increasing velocity. Okay, this is steeper. Okay, and on the other hand, let's take a look at the one below. Firstly, positive velocity, you are still moving forward. Okay, so what happens? You can see that you are actually getting gentler and gentler itself. So in this case, this is for gentler. Gentler itself, the keywords is moving with decreasing velocity. So you are still moving forward because you can see your displacement is increasing, right? But it's just that you are slowing down. Okay, so you are just slowing down. So basically you are moving, but you slowly come to nearly a stop. You haven't reached a stop yet because unless the question continues and show you that this is a horizontal straight line, otherwise we cannot assume that it will come to a stop. That's why you see I only say moving at decreasing velocity. I did not say that it will come to a stop. Okay, so be careful about this. Unless you know for sure, then you include. If you don't know, be a bit more generic and vague. Right? Now, depending on some of the questions itself and how many marks that they give you, right? Sometimes you might need to include certain values to actually help you describe it better and clearer itself. Because remember, we always assume that your teachers have no clue what you are doing. So you need to be very clear and direct with your teacher. So you should give them the values and throw it in their face. Tell them from 0 to 16 seconds, what happened? Your object is moving with decreasing velocity from 0 to 16 seconds, something like that. Okay, so you need to be a little bit more specific, throw in some numbers to help you elaborate and explain what you mean by decreasing velocity and all that. Okay, so throw in values to help you. Mostly, I would say, is for your next type of graph, your speed time or your velocity time graph. Displacement time don't really use values as often. Usually, they just mention about the time values. Okay. So now, why do we need to know all these 4 types or other types? Basically, the question itself will probably give you this kind of weird monstrosity. Now, it probably won't be so overly complicated. You'll probably look like this, like this, like this. So normally this is your speed time, not speed time, your displacement time graph. First thing, what you want to do is break it up. Okay, all these dotted lines will not be given to you. You yourself will need to break it up in this way. So point A, point B, part C. So basically, the reason why we are going to chop it up is to actually make it easier for yourself to read and to make it easier for the marker to know that, yes, I broke it up. This is what I mean by this. Now, not all the time you need to use ABC. Sometimes the question will give you values like 0, 0, 1, 2, 3, for example. Okay, they will probably give you other values, so you don't need to be overly concerned. So, what's the purpose of doing so? Once you broke it up at point A, this first thing, displacement, check number 1, displacement, check the units, number 2. We'll do the same for here. Graph is time. Second, all good. Number 3, ask yourself, what is your, hang on, number 3, check your gradient. What is your gradient? This is a displacement time graph. The gradient is velocity. So let's take a look at here. Velocity is your gradient, right? So over here, this is an upward slope, positive. Upward, positive. This is a curve up. You're getting steeper. So it means increasing. So how do I describe this? I am moving with increasing velocity. That's it. Then over here, this is horizontal. When you're horizontal, gradient is 0. Okay, when you have a horizontal, 0 gradient. Okay, the words are a bit too small, so I'm going to zoom out a little. So basically, all of the A to E are things that we're all familiar with, which is what we covered so far, right? In our previous page. But let's take a look at F and G. F and G is a little bit different because what you can see here is that these two are actually downward sloping. So normally if you have a downward sloping gradient, it means that you have a negative gradient. But we try not to use the word negative because when you have negative something, right, when you want to describe it, sometimes it's very vague and it's very ambiguous. Is it increasing, decreasing? Are you becoming more negative or less negative? Sometimes it's a bit hard to explain. So instead of using the word negative, we actually change it to in the opposite direction. So what I mean by this is, for example, if you look at F, normally this is a diagonal straight line, right? What we'll say is uniform velocity. But now, this will give us a negative uniform velocity by right. Okay, for F, you have a negative uniform velocity. If you say it like this, not wrong, but most schools will not accept it. So instead, you should write uniform velocity in the opposite direction. So basically, negative will become this phrase instead. So always use this phrase whenever you are dealing with negative velocities. Okay, we'll use it this instead of this. We try not to use this one. Okay, try not to use the word negative wherever if possible. Unless you've really forgot how to phrase it, just remember your positive and negative values just mean the direction. Are you moving forward? Are you moving backwards? If forward is positive, a negative value means that you're just moving backwards. So negative basically means opposite direction. Okay? Or you can say that you're moving in the negative direction. Some schools accept that. Okay, so next, let's take a look at this. First thing, check number one. You always want to check your axis. You always want to check your units. And then just remind yourself, gradient is a displacement, right? So this is your velocity. So for y'all that don't remember, this is displacement over time velocity. Okay. And this question, I forgot to put in the dashes. So just jot them down to make it easier for you to see which is which. Now, next, let's take a look. State. State means, well, give me a second, my stylus is not working. Okay, basically it means no calculation. Okay, no calculation needed. So in this case, your displacement at point B. So let's zoom in to point B. Point B is over here. So let's use here, dot it, and dot down. Make it a good habit to always dot your vertical and horizontal. So in this case, what is B? B is 20, 19, 18, 17, 16. And this is 10 seconds. So at B, your displacement will be 16.0 meters. Now, why is it 0.0? Because for some schools, they will need to use half of the smallest division for graphs. So if you notice over here, your smallest division is 1. Half of it, 0.5. So we'll use 1 decimal place. All right, next one, let's take a look at T, 7. So where is T equals to 7? First thing, 10, 9, 8, 7. 7 is here. So same thing, you want to dot up and you want to dot to the left. So this one is 13. Okay, but if you closely look at it, this is not exactly 13, but basically we'll round it up because we don't know any of the, because your graph itself, the scale that they use are not enough for you to determine how much is it. It is 12 point something, what exactly is the something. Okay, so because that, we'll just round up because it's closer to your 13 than your 12. Okay, Next, determine the distance. So the word determine means calculation. Determine the distance between A and C. So let's take a look at A and C. At A, same thing. You want to dot down. This is about 4. To the left is about 10. And where is C? C is over here. Dot down about 18. And you dot to the left, you have about 20. So when they ask you about the distance itself, they're actually asking you, what is this distance here? Okay. So what is the distance over there? Distance, it is just 18 minus, sorry, 20 minus 10, which is 10 meters. Okay. You want to be a bit more specific, it will be 20.0 minus 10.0, get 10.0 meters. So average speed. Every time you see a certain phrase or keywords, right? Just want to take note, when you see average speed, write down the formula first. Total distance over total time. Okay, and it is from A to C. So same thing, your distance, it will be 10 meters that we found just now, and your total time be what we need to solve. So what is your total time? Let's take a look. You can see that your time here is this. So 18 minus 4. So 18 minus 4 gives us 14.0 seconds. So in this case, all we need to do is throw in the numbers, divide by 14.0, and we can calculate it. So press the calculator, then divide by 14. Okay, did I calculate wrongly? Because I remembered that the values are hang on, give me a second. Okay, so 10 divided by 14. Okay, the number is supposed to be weird. Now, do take note, we cannot use fractions for science. So I'll leave it in the fraction because we don't know if later parts will require it. But basically, you should change it to 3SF if possible. So in this case, this will be meters per second. And because we change it to round it up, we have to put it to 3SF. So don't forget 3SF plus your units. Next, let's take a look at your velocity at 7 seconds. Okay, and if you remember just now your 7 seconds, right? These values, we don't know if it's actually on the line or not. Okay, so because of this, if you notice A and B, from A to B, this is a diagonal straight line, which means you have constant velocity, which means I can make full use of points A and B to actually help me solve what is this. Okay, so let's use rise over run. Okay, so velocity will just be your, what's the values? 16 minus 10 and 10 minus 4. We end up with 1.0 meters per second. Okay, now state and explain, are they the same? So first thing you need to state, are they the same? They are not the same. Okay, how do we know this one? The gradient at t equals to 2 seconds is steeper than depth at t equals to 7 seconds. So what's the purpose? You need to state the relationship. Since velocity is equal to the gradient of a displacement time graph, the velocity at t equals to 2 seconds is greater than that at t equals to 7 seconds. So you want to state the relationship between your gradient and your velocity itself. Because if you don't state the relationship, How would the marker know? You must always assume that the marker has no clue what is going on, and therefore you need to be very clear-cut and direct with your answer itself. So always assume. It's kind of like explaining to your parents. If they don't know anything, you need to be a little bit more specific. Okay, first thing, they are not the same because I have a steeper gradient, therefore my velocity is greater. So why is it greater? Because my velocity is the same as my gradient. So because I have a steeper gradient, I will have more velocity. Okay. Describe the motion of the objects from point A to E. Do take note, point A is here. It's not zero, it's from here. So normally when you have this kind of question, when they ask you about from something to something, break it up into its interval. Because I know a lot of you just write everything in one big paragraph, but I will suggest that you actually split it up. Okay, so let me, from points A to B, what happens? The object is moving with constant velocity because this is a uniform diagonal straight line, right? So we don't need to do too much. Same thing from points B to C. What happens? The object is moving with decreasing velocity, if I'm not wrong. Okay, it's a curve down, right? So because this one is getting gentler, you actually have decreasing velocity. So from points C to D, what happens? The object is stationary. Because you have, okay, you don't need to say it, but basically you are stationary. So from points D to E itself, what happens is that the object is moving with increasing, because it's actually steeper, increasing velocity. So you can see I just basically keep using the word velocity because this is my gradient. So I just keep using the gradient to explain, except for certain scenarios where you have zero velocity. Okay. So next, last but not least, you want to talk about your instantaneous velocity. Now, what do you mean by instantaneous velocity? Basically, they are asking you what is the velocity at this point over here. Because if I'm not wrong, it's at T14, right? So where is T14? Let's take a look at T14. So let's zoom in. Where is T14? Let me use my 1, 2, 3, 4. T14 is here. Okay, so dot up and dot to the left. Now, some students, they will sure use 19 and your 14. I do not recommend that. Why? Because if you notice, squint your eyes closely enough, it's actually not sitting on the point here itself. So how do we find the instantaneous? When you want to find instantaneous itself, basically you grab your ruler and you want to place it at the point over here. So you want to reach to a certain point where this, you can draw a very nice line across. And you have, okay. Give me a second. Lagging a little bit. Yeah, I just wanted to shift this one a little. Okay. So what I mean by this is that, let me keep my ruler away. Basically, the angle here and the angle here, which are about equidistant apart, are roughly the same. This is what you are supposed to be finding. Okay. So if you notice the points that I have, this point is the point that I'm using. All the way to the other one. Similarly, go all the way down Basically, this is now my rise over run. This is what I'm trying to use to help me find my instantaneous velocity at this point. So this is 28. And if we flip it, like this will give me a certain value as well. Okay, this value will be 26. So jot down 28, 26. The same thing, jot down for the one below here as well. Go down, keep your ruler. Right. This will be 4, and this is 14. Okay, so 4 and 14. So let's use the values to help us solve for our gradient, which is our instantaneous velocity. So velocity will be equals to your, okay, let me just write it out then. Velocity will be equals to your gradient formula, which is your 28 minus 14. Is it 14? Let me just double check. No, it is 28 minus 4 and 26 minus 14. 28 minus 4 and 26 minus 14. Okay, let me just double check. We are using, no, it's the other way around. It is y2 minus y1, not x2 minus x1. So it's 26 minus 14 over 28 minus 4. You end up with 0.50 meters per second. Okay, so if your value that you found was slightly different, maybe you got 0.54, it is fine. Because normally for instantaneous velocity itself, it depends on the line that we draw. So some students, they will draw it differently from the teacher, and the teacher might draw it differently from the student. But basically, you want to make sure that the triangle that you draw is at least half of your graph itself. So in this case, you can see I cover more than half of the graph lengthwise. So basically, this is okay, right? So we should have about 0.5, 0.4. You get plus minus a little bit. That is a range of accepted answers. So if your values are slightly different, it is still okay. But if your values are drastically different, then this is where you need to be very, very careful. Most likely you made a mistake somewhere. Or you flipped it the other way around like what I did just now. You end up with like 2. Okay, so just be careful is y2, which is your speed, your displacement minus displacement over time taken. Okay, so it's y over x, not x over y.